Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Naim bin Ghazali, Master Student Supervised under Prof. Ani Binti Idris under Faculty of Chemical and Energy Engineering. Today I would like to present my research study entitled Removal of Suspended Solid from Industrial Effluent by Using Foam Fractionation. To begin with, I would like to share about the industrial effluent came from the rubber industry, the effluent characteristic, and also what it leads to if it was not being treated well. Based on Department of Environment, rubber processing industry was one of the main contributors in causing industrial water pollution in Malaysia. From 47,096 tons of rubber, 73.7% was used to make a rubber glue. The content of the rubber wastewater consists of latex skim or serum, coagulated latex, and residual chemical from various processing stages. The characteristic was divided into two, which is the general characteristic from rubber industry effluent and also specifically from glove manufacturing industry effluent. If it's not been treated well, it will lead to water pollution, eutrophication, and also it can affect human health. This is the worst water treatment that had been done on the industrial effluent came from the rubber processing industry, which is aerobic biotreatment, up to anaerobic / blanket, ozonation, membrane treatment, and many more. So the treatment method available was physico-chemical method, physical treatment, and biological treatment. In this study, I will be focused onto the filtration, which is membrane filtration. Due to the low cost production and maintenance, it can handle large amount of wastewater in high loading rate. It is efficient in terms of reduction rate and time, and it produces less waste. Compared to the biological treatment, it needs large area for installation. It produces hazardous waste such as biogas, and it requires a lot of time in terms of treatment time. However, the disadvantages of the membrane filtration is the membrane fouling, where the suspended solid, microorganic material, and others will be deposited on the membrane surface, which will clog the membrane pore and reduce the permeate flux and rejection rate. And the membrane itself can be easily damaged if fouling problem cannot be solved. To counter the problem, I propose a pre-treatment by using foam fractionation. Foam fractionation is a technique by where it separates the surfactant from the solution by foaming, which then the foam will be coalesced at the top of the steamer and be removed into the foam collection tank. Foam fractionation is able to remove amphiphilic substances, surface active compound which is surfactant, solid organic compound, and also some bacteria. Commonly, it was used in treating aquatic life water, commonly in aquarium to remove solid content and also organic content. It also been used in industrial effluent treatment. However, less was found in treating rubber industrial effluent. The problem statement of the study is the performance of the membrane filtration system reduced drastically due to the fouling effect, which caused the blockage to the membrane pores, thus reducing the permeate flux and also the rejection rate. So the objective is to reduce the suspended solid content in the glove manufacturing industrial effluent by using foam fractionation method, to determine the optimum operation parameter for foam fractionation in terms of skimming time and also inlet flow rate, and also to investigate the feasibility of using the foam fractionation as pre-treatment to reduce the fouling effect on the membrane filtration system. For the method, the sample collection was conducted at F11 Top Glove Serian Berhad Klang, Shah Alam, Selangor from 3 different sources, which is cooling tank, cleaning tank, and also leaching tank. For the experiment, it was divided into 2 phases, which is foam fractionation and also membrane filtration. For foam fractionation, the experiment was conducted at 2 different inlet flow rate, which is 15 liter per minute and 20 liter per minute for 1 hour aeration time. The optimum parameter will be determined based on the highest SS removal rate. Moving on to the membrane filtration, which is the second phase. The pre-treated wastewater from the previous study will be filtered using the polyether sulfone lithium bromide hollow fiber membrane at 2.6 liter per minute in the flow rate at 3 bar transmembrane pressure. The data analysis will be focused onto the suspended solid removal efficiency based on the flow rate, retention time, and also skimming time, the protein content, which is burette assay, and chemical oxygen demand removal, the fouling properties analysis, and also water characteristic in terms of biological oxygen demand, COD, chemical oxygen demand, pH, suspended solid, ammonium nitrogen, and also total dissolved solid. This is the schematic diagram for the foam fractionation, where the inlet will pump the wastewater together with the micro bubble, and then it will form foam and coalesce to each other at the top of the skimmer and be removed into the foam collection tank. And at the bottom, the pre-treated wastewater will be collected for further filtration by membrane filtration module. This is the module that being used for the membrane filtration method. The permeate will diffuse into the hollow fiber membrane and flow out through the permeate point, and the retentate will be flow back into the feed tank, circulate back into the feed tank. Moving on to the result and discussion. This is the graph for the percentage reduction of suspended solid. At higher inlet flow rate, it gives shorter retention time, and at lower inlet flow rate, it gives longer retention time. As shown in the picture, at shorter retention time, the suspended solid removal percentage was higher compared to the longer retention time. It was supported by Peng, Oh and Zhou 2003, where they found that the removal of suspended solid was found at highest rate in shorter retention time. In terms of the skimming time, shorter hydraulic retention time reduced TSS much faster than longer hydraulic retention time. Peng, Oh and Zhou also found that the shorter retention time, the concentration of the TSS in the water decreased more rapidly. Here is the protein content and also the chemical oxygen demand for the raw effluent, pre-treated effluent, and also filtered effluent. The removal of protein achieved in this study was more than 70%, and for this chemical oxygen demand removal achieved about 45% respectively. This is the result and discussion for the membrane filtration. Here is the permeate flux for the raw effluent. As you can see, the permeate flux decline was significantly high due to the presence of the high content of solid and residual, which will clog the membrane pore and reduce the rejection rate and permeate flux. However, after being pre-treated, the flux decline show lesser, which is less than 20%. It shows that the solid and other residual was removed during foam fractionation method. Here is the falling properties for the raw effluent and also the pre-treated effluent. Both show good flux recovery ratio, which tells that the membrane can retain its initial flux after being backwashed by tap water for 1 minute. The main focus is the total falling, where the total falling for raw effluent, which is 57.7, 39.5, and 12.5 for cleaning, cooling, and leaching. However, after being pre-treated, the total falling reduced to 11.4, 8.6, and 4.4 total falling. In terms of flux recovery ratio, total falling, reversible and irreversible falling, pre-treated wastewater shown better falling characteristic in terms of high flux recovery, low total falling, high reversible falling, and low irreversible falling. This is the water characteristic as shown in the table. After being filtered, most of the parameters comply with the water discharge standard as stated in EQA 1974. However, some parameters such as COD and umbilical for leaching tank might exceed the limit, but I believe that it can be solved with extensive treatment. In conclusion, it was demonstrated that the application of foam fractionation as a pre-treatment was capable to reduce the suspended solid in the rubber industrial effluent, and also capable to reduce the falling effect toward the membrane surface in membrane filtration. At high inlet flow rate, it showed highest capability in reducing solid from glove manufacturing plant effluent compared to the low inlet flow rate. Falling analysis proved the application of the foam fractionation as a pre-treatment by showing less declination in permeate flux and less total falling obtained from the wastewater after being pre-treated. Lastly, future improvement is needed in terms of optimization of foam fractionation and membrane filtration method, as well as the improvement in skimmer design to improve the separation. Being said that, that's the end of my presentation. Thank you.